We'll get started in about 2 minutes or so. Hope you all are having a nice Thursday, and you're able to work through the stuff okay on Blackboard. I know we had some issues with pre-labs and some other things, so there's still some mastering chemistry stuff that we're trying to work out. But it looks like things are coming in, and I'll keep trying to catch up the grades as best I can. Wait another minute or so before we get started. If you're following along with the material from Blackboard, let me turn this off. So today we're going to finish going through these notes as we did before. We're also going to look at this naming practice worksheet. This is not due. This is not homework. This is just extra practice on Blackboard, but I encourage you to try it. We're going to do a few of them together, and then I encourage you to work on some on your own as well. Hey, good evening, Daisy. Hey, Maria. Thanks for tuning in. Hey, Alyssa. Okay, well, to recap from Tuesday's, whatever you want to call this, stream, session, class, we talked about two types of different naming rules or naming schemes or naming, however you want to call that. We looked at the covalent compounds where we use these prefixes, and we looked at the ionic compounds where we didn't use those, and we just said the metal and the nonmetal. So calcium iodide versus carbon tetraiodide or something like that. If you remember, we talked about the most important distinction there is you have to first decide, is this a covalent compound or an ionic compound? And if we go back to this flow chart, basically what we talked about last time was ionic right here versus molecular here. They called it molecular. I don't love that term because there are plenty of covalent compounds that are not molecules, that are not molecular. But that's still kind of the thing that we were talking about. So last time we talked about metals that form only one type of ion, and then we talked about these non-metals here. All right, so let's go to where we left off here. And there was a little bit of practice that we didn't quite get to do. So if you didn't get a chance, try to fill this out. Take a couple minutes as just a way to refresh your memory from last time. See if you can write down some names for these compounds which follow the rules that we talked about last time. And similarly, see if you can write down some formulas for these compounds over here, which we also, so those are just following the rules last time. So you have to decide ionic or covalent and then write it accordingly. If you're watching here, you don't have one handy, here's the periodic table again. That may help you out, particularly with this side of it. I don't know if those words might be a little too small for you, but if you've got your own periodic table, that can be helpful. I got to answer a question on Discord here while you do that. All right, question. For naming covalent compounds, if both only have one atom, how should we name them? Use mono for the second. So it depends again on the type of compound. So if it's an ionic compound, no, you don't use any prefixes. But if you decide that it's covalent and they each only have one, then yes, you'd only use mono for the second. Yep. All right, so I also wrote the answers on here. So when I take away the periodic table, you'll see you're almost right, except for the very last one there on the left. Let's see if you can figure out why. All right, I'm going to take away the periodic table, which will show the answers here. If you're still working on them, that's fine. You don't have to do them super quickly, but just so we have time to talk about all the other stuff. Yeah, Daisy, that's correct. It's covalent, and so you need to have the prefixes. So that should be dinitrogen trioxide. The first three don't get any prefixes because those are all ionic. We've got metal, nonmetal, metal, nonmetal, metal, nonmetal. So no prefixes there. And then if we move over to the right, these are actually all ionic. There are no covalent compounds in there. So to get the right ratios, we have to use the charges. So in some ways, this can be a lot more difficult than the actual naming because we have to know that calcium is Ca2 plus and bromide is Br minus. And because we have 1 minus and 2 plus, that means we need 2 of these for every one of those. And so it has to be a 1 to 2 type ratio. Similarly with aluminum and sulfide, 3 plus and sulfur 2 minus, potassium K plus, phosphide P3 minus, barium Ba2 plus, and iodide I minus. Quick review there. To find those charges, we're going to use the periodic table. So these are ions whose charge is always known because they all only ever make one type of ions, and these are the ones that are in the columns shown up here. So any element from one of those columns has what we call a predictable charge, or it only really makes one type of ion. And so therefore, if we see, for example, calcium or barium or magnesium or strontium, those are all in this column here on the periodic table, the alkaline earth metals, and they're always going to be at +2 when they're an ion. All right. So any questions about those rules from last time before we go on to the next type of compound? All right. So as you might have noticed when we looked at that periodic table up here, we kind of left out a whole lot of stuff. And those are elements that make compounds as well. So we need to find a way to name those. And the reason that we didn't talk about those, or that we haven't talked about those yet, it's not that they're harder or anything. It's just that they make more than one type of ion. So iron chloride, for example, that's just not a specific enough name because there are actually two different iron chlorides. There's FeCl2 and there's FeCl3. And the reason there's two different iron chlorides is because there are two different types of iron ions. There's this iron ion on the left, which is Fe2+, and then there's this one over here, which is Fe3+. So those exist. Both of those ions exist. So to just call a compound iron chloride, it just isn't specific enough. It doesn't tell us which compound we're talking about. So we need to specify the actual ion that we care about. And we do that by actually saying the charge of the ion in the name. And we put it in parentheses just after the name. So this one down here, FeCl2, we would call that iron 2 chloride. And FeCl3 we'd call iron 3 chloride. So let's figure out what that looks like and how to deal with that with a couple examples. Okay, so this first one is manganese, and it's a 2+ cation. And if we want to pair that with oxide, which is a 2- anion, we know from last time that we need to adjust the ratios so that we have an overall neutral charge. So that's going to look like MnO, because 2+, 2-, so they have the same charge, so we don't need to change the ratio at all. But then look at how it's named. Manganese 2 oxide with the 2 as a Roman numeral. And this is perhaps the most missed part of all of the naming stuff that we do, is forgetting what that 2 corresponds to. That 2 is the charge on the manganese, not the subscripts. So notice, neither of these elements have a 2 down there, right? So that 2 does not correspond to the subscripts. It corresponds to the charge on the cation. In this case, manganese. All right, so let's look at the next one. We've got magnesium and nitride, so a 2+ and a 3-, so we can do the crisscross thing if you want to think about it that way. And that gives us Mg3 N2. So how would we name this one? I'll give you a hint. It's a little bit of a trick question. So be careful here. Yeah. This is not manganese anymore. It's Mg, which is pretty similar. Totally reasonable mistake. But Joey's got it. This is actually magnesium, which is not in this category of changing its charge. Magnesium's, we just talked about that one, right? Up there, or which way? That way, over on the left, number 12. So that's in the alkaline earths. That's a +2 ion. So this one's just going to be named magnesium nitride. So notice when we have to say the charge, we use the parentheses. When we don't, we don't. And so magnesium in this case is +2. So if we were to use the parentheses, we would call this magnesium 2 nitride, not 3, but magnesium 2, because the charge is +2. But because of where it is in the periodic table, because it has a predictable constant charge as an ion, we don't actually put anything in parentheses there. All right, so let's look at the next line. This time we're only given the name, and we'll work backwards from there. Cobalt 3 fluoride. So if you're only given the name and you want to put the compound together and it's an ionic compound, the best thing to do first is always write the ions with their charges. So it's going to be hard to put them together in the right ratios if you don't have the right charges first. So Cobalt 3, one nice easy thing about this type of naming is we're told the charge right there. So if it says Cobalt 3, we know that the cation is going to be CO 3 plus. We're told the charge. That 3 tells us it's Cobalt 3. For the other ion, we know it's fluoride, which we can look up on the periodic table as F. We may not know the charge right away. So we look at the periodic table and we see, oh, okay, F is right there. That's column 7. That's those are all -1. Those are called the halogens. So that tells us that that's got to be -1. So we can put a -1 there. Now we know a 3 plus and a -1. We know how to put that together. We need 3 of these for every one of these. So that's COF3. All right. So then the last one is a little bit different because we're told the chemical formula, but we're not told the charges or the ions, and therefore we don't know the compound name. If you're told the chemical formula like this, and the goal is to eventually find the name, you still need to break it up into its ions first because we need to figure out what the charge on the cation is. So in this case, all we know about this is Cr. And if we look in the periodic table, Cr is number 24, so on the top row over there. And that doesn't help because all this stuff in the middle can have lots of different charges. So all we know is chromium has different charges, so that puts us in this category where we need the parentheses. So all we know right now is this is going to be, whoops, let me get rid of the periodic table. So this is going to be chromium something, and we know oxygen as an ion is oxide. So it's chromium something oxide. We don't know what that something is, and we're not going to know until we figure out what the charge is. So let's look at how to do that. If we look at the chemical formula, we don't know what the charge on chromium is, but we do know what the charge on oxygen is, oxide, because that's one of those elements that always has a predictable charge, always has the same charge. And in this case, it's oxygen, so it's -2. Oxide is always -2. So we know it's got to be -2. So then what does the charge have to be on chromium in order for this formula to be neutral? Two. Yep. +2. So very good. So that's going to be chromium +2. And that tells us exactly what we need to finish the name. So we can put a 2 in the parentheses there. Yeah. Good job, everybody. All right. So same thing like before. Let's try this out. I will tell you nothing is tricky here. These are all examples of exactly this technique. So see if you can come up with names from formulas and formulas for from names for these 6. And I'll put up the periodic table and do it in the background again. In fact, you know what? I'm going to take myself out of here for a second just so you can see the whole periodic table. I'm still here. if you're getting stuck here or you're not sure about something, try to answer it as best you can. But then if it's something you can easily ask, go ahead and ask it, and then I'll address it when I open this back up again. That's okay. You don't have to apologize. We're just learning. Let's go through and see if we can figure it out together. So here are the answers for those. And let's go through it and talk about how we came up with those. So for the actually, let's just start down here because I have a little room to write. So for zinc 2 phosphide, actually, and this will work for all of these on this side. What are you going to do? First, we have to write down the ions and then try to put them together into a compound. Sorry, my microphone's moving. Okay. So our ions are zinc 2. Zinc 2 is zinc plus 2. And actually, often you'll see zinc not written with the 2 because zinc only ever makes a plus 2, but that's not something you have to remember. You can always look it up if you need to. And then the other one is phosphide. So we may not know that charge just by looking at it, but we can probably guess that phosphide has something to do with phosphorus, P. And that's where we would come back to the periodic table. And, oh, right by my head here, here's phosphorus. That is, so remember it's -1, -2, -3. So phosphide's going to be a -3 ion. So that tells us our two different ions that need to come together. And we know whenever we have a 2 plus and a 3 minus, or a 3 plus and a 2 minus, you have to switch those numbers so that you get the overall formula as ZN3P2. Notice again that even though that zinc 2, even though everybody wants that 2 to mean a subscript 2, it's not. It's the charge. So the 2 is the 2 plus right there. Okay, let's jump over to the other side and let's try this first one. Manganese Ii Chloride. So how did I come up with that name? Well, I looked at this formula, and once again, I split it up and I wrote down the, and I did it in my head, but I was thinking about the individual ions. So that looks like this. I saw MnCl2, and I said, okay, well, I'm going to split that up into Mn and Cl. And then I know the charge on Cl because chloride is always -1 in the halogens. And the formula tells me I have 2 Cl's for every 1 Mn. So that tells me that the Mn has to be +2. So that I can have 2 chlorides to 1 manganese. Okay, so that's how I found that it was Mn +2. And then I wrote the name, and in the parentheses, I have a 2 because of the 2 plus, like that. So it definitely takes practice to get through these and do these. One thing that helps is just thinking about always breaking them up into ions before you do the rest. Eventually, with practice, you might be able to just look at the formula and write the name. But at first, it's always helpful to look at the formula, break it apart into its ions, and then try to write the name based on those ions that you see. And same thing with going the other direction. If you want to find a formula from the name, write down the ions first that the name is representing, and then finally try to put them together and balance the charge. Okay, so we'll practice this a little bit more in a bit. I want to add one more piece to this. And that is something called polyatomic ions. So with polyatomic ions, so far all the ions we've looked at are monoatomic ions. They have one atom per ion. So like you have copper, you have sulfur, you have phosphorus, oxygen, whatever, one atom. But there are also ions that are made of multiple atoms. Yeah. And there isn't like a new way of naming those compounds. They still follow the same rules that we've already talked about, but we have to watch out for them because they're a little bit different. So here are some common polyatomic ions. And this little box that you'll see here are some of the most common ones that you definitely want to know. And actually in the objectives on Blackboard, it says, here are the ones that you absolutely need to know. But the reason I kind of put this in parentheses, this was prepared by another faculty member. Some people really like these kind of like little phrases, these mnemonic phrases that help you to remember how things are set up. Personally, they don't work for me. It's too hard. Like, it takes me too much work just to memorize how the whole thing works out. It's easier for me to just make some flashcards or something and remember it. So that's what I would do. But if you're the sort of person who likes that kind of thing, this might be really helpful for you. So I wanted to leave it in there for those of you who do that. But here's the thing about polyatomic ions. They have a name, they have a formula, and they have a charge. And there's not really a good way at this point to kind of figure that out. Like some of the ions we could figure out by looking at the periodic table. With these, you really can't do that. You just have to know this is a nitrate ion, this is the formula, and this is the charge. And so Alyssa asks, do we have to memorize them, or will you have access to them? And the answer is you will have to memorize a few of them, but not all of them. So look specifically in the objectives on Blackboard for which ones you need to memorize. I believe it is these 5 plus hydroxide and ammonium. So there are a few that are so common that you need to memorize them. And honestly, yes, it'll take some work at first, but by the end of the semester, you'll just know them because we'll use them all the time for lab and for everything else. So, you know, they're very common ions. You've probably heard of some of these already, even if you didn't know the formulas and the charges. So we've got nitrate, carbonate, chlorate, sulfate, phosphate. Notice that almost all of the polyatomic ions do not end in ide, whereas whereas all the ions, the monoatomic ions that we just talked about, do end in ide. The anions do. There's a couple exceptions to that, hydroxide and cyanide. Oh, okay, here. So we did write them down. Yeah, so ammonium is the only positively charged polyatomic ion. This one kind of throws people off sometimes because the name is so different from the names of the atoms that are actually in the formula. So ammonium, it sounds like an element, and I've definitely seen on exams people writing like AM or something like that when they see that, but we just have to know that that's a polyatomic ion and it's actually NH4. Hydroxide, you've probably heard of, like sodium hydroxide. Hydroxide is OH -1, cyanide, CN -1. So yes, you just have to memorize them. There's not really a good way of figuring them out from like a periodic table. But the good news is once you know them, it's no different from all the stuff we've just been doing. So let's look at how we name or write formulas for some ionic compounds that include polyatomic ions. All right, so take a look at this one. our cation is aluminum, and I don't know why it says plus there. That should be 3 plus. Sorry. And in this case, we've got aluminum and carbonate. So our anion is actually this whole thing called carbonate, and this whole thing has a -2 charge. So we're looking at balancing a 3 plus charge with a 2 minus charge. So we do that same crisscross thing where we're going to put the 3 down here and the 2 over there, because that's how we balance the charges. So we have 6 plus and 6 minus overall. And because our polyatomic ion has some other things in there, just to avoid confusion, we put some parentheses around it before we put our subscript. So imagine if this were just oxygen, just oxide, O, O2 minus. In the formula, it's going to behave the same way. We would have an O, and we would have 3 of them, because aluminum oxide is Al2O3. So same thing, we just substitute this big chunk instead. And then with the name, again, it's named the exact same way with the same rules, except that this one's also wrong. Man, this was rough. Sorry. This should be aluminum carbonate. While we're talking about that, by the way, if you've heard aluminium, that is also a correct way of spelling and pronouncing aluminum. That's more of a British English version of it, but that's totally fine if that's how you learned it. So we have aluminum, which is always +3, and then carbonate. And we don't have anything else there. We don't use prefixes. We don't break this up and say carbon trioxide or something like that. That's just the ion, and its name is carbonate, just like oxide, and we just stick its name there. All right, let's look at the next one. Barium acetate is the name here. So let's say you encounter this name and you want to know what the formula is. You need to figure out the formula. Just as before, we want to first write down the cation and the anion with their charges, and then from that we can figure out the chemical formula. So barium, that's an element from the periodic table. That's going to be our cation, Ba. And to find its charge, that's one that we can get from the periodic table because it always has the same charge, and that's +2. And then the anion in this case is acetate, and that's not something we find on the periodic table. That's not a monoatomic anion. So we have to go look at our chart of polyatomic anions, at least until we memorize them. And we find acetate right here, C2H3O2. And so we just write it down directly from the list. Eventually, hopefully that's from your head, but for now, from the list. And you write down the whole thing, the whole formula, including the charge. So we've got now a +2 cation, a -1 anion. So when we put them together in a formula, just as before, we want 2 of these and 1 of these. All right. Questions about how to do that so far, or any specific concerns? We'll try the next one. Actually, go down one more. Okay, then let's try some more. So this one, this is kind of a weird one because it's 5. It's not actually an ion exactly. Ions can't really have that high of a charge. There's something else going on there. We don't need to get into it. But let's pretend it is what it is. And we've got vanadium with a 5 plus charge there, and we've got a chlorate ion here. So again, we'd see that negatively charged collection of atoms. It's not just one atom, it's a collection of atoms. And so we need to find a name for that. And to do that, we need to find the formula and the charge, and we see it's up here. ClO3 is called chlorate. So when we go to name that, that's where we get that name. And then vanadium is V. And that one is in the middle of the periodic table. It's like right around there. And so therefore we need to specify the charge. In this case, it's 5. And then when we put this together, we want one of these for 5 of these. So this is going to be V ClO3 5. And I should check that. I'm not sure that compound actually exists. I'll need to check that. But that's how you would do it. All right. And then for the last one, the tricky thing here, it's not really tricky, but the thing that might throw you off is that ammonium that's the polyatomic ion. So the cation here is NH4. Yeah, good question, Daisy. Chlorite. So be careful there. Those are actually different ions. So chlorate is ClO3 minus 1. Chlorite is ClO2 minus 1. So we are dealing here with ClO3 minus 1, which is chlorate, not chlorite. It's a good time to say also that this is also a common problem with polyatomic ions, especially for people like if English isn't your first language. Some of these names are very similar to the monoatomic ion. So like nitrate and nitride, and there's also a nitrite. So like very small differences in letters actually mean a totally different ion. So you've got like sulfate is SO4 minus 1. Sulfite is SO3 minus 2. Sorry, sulfate is minus 2. Sulfite is SO3 minus 2. And then there's also sulfide with a D, which would be S minus 2. That's the monoatomic one. So some very similar names there. And just practice and seeing the different ones is what will help you not get tripped up there. All right, so to finish this one off, the anion here, again, nitride, watch that IDE ending, with the exception of hydroxide and cyanide. All the other ide endings are going to be monoatomic ions. So that's going to be just N and a minus 3. So then our formula, we need 3 of these and just 1 of these to get a balanced formula. So that's going to look like NH4 3N, and that's ammonium nitride. All right. So this last bit here, this is really like kind of the overall end here. Can you, oh wait, no, I'm sorry. These are all polyatomic ions. We haven't gotten to the overall summary yet. So these are all compounds with polyatomic ions that are still named with the same rules we saw before, except that they also have these polyatomic ions in them. And I see one mistake here. That's not how you spell manganese. But yeah, I'm going to let you try these. I would encourage you to please do try them and let me know what you've got at some point as you're working through them this weekend or whatever, so that if you're having trouble, we can see what kinds of issues you're having there. And then if we jump over to the naming practice here, this is really what you want to ultimately be able to do with this. So take any random compound and figure out if it's ionic or covalent, and then name it. Again, you're not going to turn this in. This is for practice, but please do it. You should be able to just jump in here somewhere, pick one out, and figure out what kind of name it's going to get, and then put that name together. So let's try one. Let's try this one right here, SO2. So we're going to go through our flow chart, and our first decision is always, is it ionic or is it covalent? So what is it in this case? Is it ionic or covalent? Yeah, this one's covalent. So it looks like those polyatomic ions we just talked about, but since there aren't multiple of them or metals or anything like that, that's got to be covalent. So once we know it's covalent, we can use our nice prefixes and just call this one sulfur dioxide. That's it. Great. Let's try one more. What about this one here? So is this one ionic or covalent? Yes, that one is ionic, and we can tell because it's got the metal here, right? So this is ionic, but when we see that it's ionic, we need to make one more choice also, and that is it a metal that has variable different charges or just one fixed charge? And so to do that, again, we look at the periodic table. We find that Ti, we got to look up the name anyway if you don't know it. It's in the first row, a little ways down there. That's titanium. And because it's in that middle section, we know it can have multiple possible charges. So this is going to be one where we use the parentheses. And then the other thing that happens here with this one is we have to deal with a polyatomic ion. So the anion here is SO4, and you may not know that one offhand just now. Eventually you will. But you would look that up in the table and we'd say, okay, SO4, that's sulfate, and it has a 2- charge. So that's written sulfate. And then it's also important to know the charge because that's how we figure out the charge on the metal. So to know what goes in this parentheses, we need a little space for that. We'll take our formula and write it out. And sometimes it can be helpful to actually write out like the entire formula, like how many of each piece are there. So I've got 1 Ti and I've got 2 SO4s. And then I know from my table, from my chart of polyatomic ions, that sulfate always has to be -2. So both of those sulfates in the formula are -2. And then that tells me that my charge on titanium has to be +4 to balance out the 2 -2s. So to finish my name here, in the parentheses, I'm going to put a 4 because we've determined that the titanium ion in this compound needs to have a charge of +4. All right. And that's how you do that. So the answers to these are also posted right underneath them on Blackboard, but please try them on your own first without looking at answers. Just, look up polyatomic ions or something if you want. But see if you can really get the names down. And then when you look at the answers, if your answer doesn't agree with that answer, then compare and figure out what happened there. And if you're not sure what happened or why you keep getting them wrong, let me know. Yeah, I can definitely do another one. Let's go the other way. How about number 29 here? Manganese Ii phosphate. So we've got the name, and we need to put that compound together. So we know it's ionic. We know it's a metal with multiple charges. If we look up the symbol for manganese, you'll find that it's Mn. And then remember that in the parentheses, with the parentheses there, that tells us the charge. So it's manganese 2. So that's going to be manganese +2. And then for the anion, we've got phosphate. And we have to be a little bit careful here because there's a few different anions that have this phos start. So make sure to look up that word carefully on your chart, and you'll find that phosphate is PO4 3 minus. So now we've got our two ions, manganese 2 plus and phosphate 3 minus, PO4 3 minus. So we're going to put them together so that the overall charge is neutral. So we need 3 of the 2 pluses and 2 of the 3 minuses. We've seen this pattern several times now, so that's Mn3, PO4 2. And I think there's some more practice ones at the end of this too. Oh, maybe not. Okay. All right. So the last bit here is acids. And acids, you've used some, you've probably heard of some of these names before. But this thing that's special about acids is they kind of act like ionic compounds with a hydrogen in front. And acids are not ionic compounds, they are covalent compounds, but they act like ionic compounds. So just to be correct here, I'm going to change this to sort of. They do form ions in solution. They are electrolytic in that way, but the actual molecules are covalent. But that's what's kind of weird about them. It's helpful if you think about hydrogen as being a +1 ion, and that can kind of help understand how these things work. So if you had something like everybody's favorite common acid, hydrochloric acid, the way you're going to name those is by saying hydro and then the name chloric and then acid. The nice thing about acids is they're always named acid. So that helps with that. You can have these monoatomic or binary acids where you have a hydrogen and then just one other atom, and those are always named in that way. So it's like hydrochloric acid, hydrobromic acid. There's only a handful of them. And then you can also name acids that are made from hydrogen and the polyatomic ions. So some common acids like sulfuric acid or nitric acid or phosphoric acid or carbonic acid, those come from the polyatomic anions with hydrogen. And so those have some slightly different names. So when we work with phosphoric acid, we're talking about taking phosphate, which is this ion, and making what is essentially what feels like an ionic compound with hydrogen instead of a metal. So PO4 is 3 minus, hydrogen is, not 3, hydrogen is +1. And so to put those together in a compound, we need 3 of these, right? 3 pluses to balance out the 3 minus. And so that formula becomes H3PO4. Again, there are only a handful of these acids that are named this way that you have to worry about, and we will use them in lab and we'll see them a bunch. So I'm generally not as worried about that. It's this stuff that gets people sometimes. So the naming practice is a good place to go with this. There's also plenty of practice in Mastering Chemistry as well as in the linked book. And this is a common source of trouble for chemistry students all over the world. So if you look up ionic or covalent naming practice online, you can find hundreds of other practice documents and practice problems. So the more you can practice these, the better. And then once you've got it, and you know the rules, and you'll be fine for the rest of the semester. So before I let you go with that, on Tuesday, even though we're going into a new unit, we'll come back and review this some more and do a little bit more practice then. So if you get a chance to practice it, hopefully you'll get a chance to practice it. If you can't get some questions to me before that, at least come on Tuesday and we'll talk about it some more. So before we say goodnight tonight, are there any more questions about this stuff? All right. I hope there's not too much lag, but I'm not seeing questions. There you go. Can we do one of each on page 11? Yeah. Oh, the acids. Yeah, we didn't practice an acid. Let's do that. Okay. So let's look at the table first, and then we'll look down here also. So with these acids, remember these are acids, all acids. The cation is always hydrogen. So if you see H in the beginning of a formula, it is almost certainly going to be an acid. So look at these chemical formulas that are written here: H2S, H2SO4, H2SO3, HNO3, H3PO4, all acids. So we write the hydrogen first, and that's how we really know that it's got to be an acid. Okay, so let's look at one. Let's look at this one down here. So hydrogen with carbonate. So to figure that out, we're going to put the chemical formula together, and this is going to work just like the other ionic compounds, even though it's not maybe technically ionic. But we have CO3 2 minus, and we have H plus. So to put those together, we need 2 of the H pluses. So our overall formula is going to be H2CO3. So to name this now, we're going to take this carbonate, this name of this ion carbonate, and we're going to change the end 8 to IC, IC. And so instead we call this carbonic acid. Okay. Let's look at one the other way where we're given a name and we have to figure this out going the other direction. So like for this one, this last one, nitrous acid. So there are 2 different possible suffixes for acid. There's OUS and there's IC. And if you're not sure what one of them is, then you can look up the other one. But basically, the IC comes from the ion with the most oxygen, and the US comes from the ion with less oxygen. So in these compounds, we've got nitrate, which is NO3, makes HNO3. Hold on, let me move this up so you can see that. Oh, you can't see. Okay, just gonna move it over. No? Okay, I can't move it over. HNO3 is nitric acid. That's actually over here. So nitrous acid is always going to have 1 less oxygen. So instead of HNO3, it's HNO2. So if it comes from an ion with an 8 suffix, like carbonate, acetate, sulfate, nitrate, the 8 becomes IC, IC. If it comes from an ite, ITE, then the suffix becomes OUS. And so nitrite becomes nitrous acid. Nitrate, which is this next one, would become nitric acid. Again, if you look at the objectives on Blackboard, you don't need to know all of these acid names. You'll be able to look some of those up just in the same way that you don't need to know all of the ion names. You'll be able to look some of those up. So there are a few really common ones that you need to know: nitric, sulfuric. You can look at the list to make sure you get all of them, but you don't need to know everything that you see here. So pay attention to those objectives on Blackboard because that really tells you. When I say objectives, I mean like it's like a list of bullet points right at the very top of the module, and it says like these are the things you need to be able to do for this chapter. And I believe that that specifies which ions you need to know. All right, other questions or other things you want to look at? Well, let me know if you got more questions. Also, if you find this format difficult to ask questions, if you're just listening and you're not typing in the chat at all, or if you are typing in the chat but you find it annoying and you'd rather just talk, we can always meet in like a video chat type room other times during the week if you have specific questions and you want to go through them just like an office hours kind of thing. So let me know if that's an easier way to get your questions answered. Otherwise, I will see you Tuesday morning and half of you in person on Wednesday. So thanks, everybody, and have a good night.